Well, good morning, everybody. I think we'll get started here this morning. Welcome to the 2018 Jumpstart. This is your FRC overview of the control systems. I'm Todd Kruze. I'm currently the lead mentor for 7068, the Mechanical Masterminds, and I've been on a TNT 3840 for the previous 5 years. So we're also live streaming this out today on the 2052's channel. So we're glad everyone could make it today. So if you guys have any questions at any time, please stop me, okay? This is meant to get as much as you guys can about this program. So I always like to ask right away, how many of you guys is your first year in FRC robotics? Never seen this stuff before. So like usually we have almost 70% of you guys have never seen this control system at all, right? So good, we're gonna go through a lot of things today. And so I found this thing on the web the other day about applying for a job at IKEA. And he says, make a chair and take a seat. So it's the same thing here. We want to build a robot, we want to be able to drive it, right? And in my world, I'm an electrical engineer full-time, controls basically, doing software and electrical design. And they love to talk about the electrical engineers and that, but they can't talk without us. You can't move anything on a robot without the electrical and the control system on here. So it makes a lot of sense to put that on there. So we want to go through this and figure out what we need to do to make this robot move. So here's a big snapshot of the entire control system. It's got a lot of components on here, and we're going to break it down here in a minute. But you can see the big rocks on here is you got the Robo Reel over to your left there, the power distribution, and then you got your voltage regulator and other modules in here. And then all your motor speed controllers and different sensors and stuff you can interface with your control system, as well as cameras. So let's just dig right into it. The power distribution, the PDB here, this is the main hub where all your electrical is going to be coming in there to power your components on your board. There's a lot of features on this board, so let's look at some of them. This is the only way, and I've seen a team this past year use the black wire, the common wire, to go through the breaker. Not a common thing to do, but it's been done in the industry. But even though it's not on the robot inspector sheet, this is the only way first says you should wire your robot from your battery to the circuit breaker, then to the power distribution board. So at any time, if that trips, your power is and you have no 12 volts going throughout your system. And the bottom here shows these with the fuse plug-ins and stuff on here. So everything's individually fused with auto resets. This is your pneumatic control module, always known as the PCM. Now you're going to hear a lot of different acronyms today because we like to just call VRMs and PDBs, PCM modules and that, but we want to make sure you understand this is your pneumatic. So if you're going to use pneumatics on your robot, you need to use this module. You can use multiple of these modules because these modules only have certain amount of outputs on there. This is a CAN device as well. So when you're considering using pneumatics on your robot and you want to use some solenoids to fire some cylinders, here's the thing you need to keep in mind when you're purchasing parts. There's this little thing in the middle called 12 volts and 24 volts. Now, does anyone know how a relay or a solenoid works? No clue? Anybody?
If I'm correct, a relay is a switch operated by an electromagnet.
Right, but it takes a voltage, right? So when you're purchasing your solenoid, you need to make sure you're going to purchase a bunch of 12s or a bunch of 24 volts. Because you can't mismatch. Now again, you can have multiple of these modules on your robot. You can have one that's set for 12 volts and you can have one set for 24 volts. But within the same module, you cannot have 12 and 24 volt modules. It won't work that way. You'll have intermittent issues with your solenoids firing on here. So when it puts an output out, it's going to put that voltage on there. Yes?
Is there an advantage to 12 versus 24 volt?
Not really.
Okay.
Don't really, you know, voltage. I mean, this thing's got a booster and it'll make the 12 to 24 volts output. Industry-wise, standard 24 volts when I make any of my connections on my PLCs at work, where industry's standard 24 volts. But that jumper needs to be in the right location. So if you're using 12, You may put it in the 12 and then make sure all your coil voltage, which is the key, on your solenoid, when you look at the part numbers and really look at the specifications on these sheets, make sure it's all the same voltage. We get them questions quite often because I'm also a CSA, which is a Control System Advisor, and this is part of the troubleshooting sometimes we see in the pit. It's got the CAN connections on here. And it's got the 12 volts, which comes off the power distribution place on there. There's a spot that will say PCM on there. And then most important is your pressure switch and compressor output. These must be wired on here, and the CAN needs to be on there to communicate with the Robo Reel from your program. So on the compressor, there's a switch on there. And this ain't the pneumatic class, that's down the hall, but there's a switch here you need to wire into it, because that's going to tell you your compressor shut off. And then it wires right into the compressor off this module. And then you'll see your 8 different outputs you can do by solenoids. So here's a little more close up. Here's your switch right here. This is the control through the CAN. It can be switched from 12 to 24. So pay attention to that when you're wiring it up. And then here's a close-up of your pressure switch that needs to be wired in and your compressor out. Now everything on the FRC control boards is color-coded, red and black. So red's your hot, which is your 12 volts, and your DC common is your 5 volt, is your black on here. Completely opposite of what industry uses for low voltage, but we'll ignore that. Just use the black and the red for everything. Yes?
What does CAN stand for?
The CAN, it's basically a data highway. It's got the high and low on there, and that's the way it communicates over high-speed serial there.
So it's a serial?
It's like a serial communications around there. That connects all your nodes together and can be addressed like a 485. Anyone who's 485 in the industry. Next would be the voltage regulator module functions. Now this is where you got to be careful on here putting lights and fans on here. I had a team member a couple years ago decide to hook some fans up here, blew this module out. It's a $70 module. And then causing time to order another one for replacement. So you feed the 12 volts from the power distribution board. And then you have different outputs on here. Now mainly what we use the voltage regulator for FRC on here is to power the radio. Because you've got the constant voltage on there keeping it at 12 volts on the radio. But beware of these things on here, because look at it, it says 5 volts and it's a 1.5 amp limit and 2 amp peak. So pay attention to the different voltage on here, and then it's got LED controls on there. But from wiring point, you're going to take the 12 volts off of here and run it right to your power distribution board, which has the fused on it right there. On the end, the 20 amp right there. These are all labeled on the power distribution board, and that's the only way you should be wiring it, and the inspectors usually check that as well. So that's a brief overview of the power distribution, the voltage regulator module, and the pneumatic control module. Next we're going to talk about some speed controllers, the motor controllers that can run your motors on your robot. So there'll be a few of them here. You'll see the Talon SR, the one up on the right that has a fan on it. That's a PWM. So I'm going to talk about PWM, pulse width modulation, or the CAN connection. Now, anyone know the difference on connection-wise from a PWM to a CAN?
PWM isn't that. PWM uses pulses pulses at a certain frequency to determine speed. CAN is a serial standard used to tell my controller what speed to use.
Right. So on a connection standpoint, what's the main difference between the two, connection-wise?
CAN can be daisy chained together using green yellow wires, or
Yep.
typically, and PWM has to run back to the Robo Reel every time.
Correct. So you understand it. So when you're looking at speed controllers and integrating them in, and there's a lot of different features between these different speed controllers, what you're saying is everything has to go back to the Robo Reel right here. So right here you'll see my, and it's hard to see for everybody, but when we get the Robo Reel, I'll show you that. All them wires got to run back to it. Where the CAN bus stuff, we can daisy chain them together, and we only have one set of wires going back to the Robo Reel. So here's the motor controller produced by motors as well as regulate the speed variation. Talon's a very powerful thing. This one's around $90 from any of the vendors. And this has the capability of a data port that you can put encoders, limit switches, the pigeon stuff with the IMU stuff. Everything is daisy chained with the CAN bus on here. There's another close-up of that. Unlike the regular Talon, which is the SR version on there, that's just PWM. They're very compact. You can shove them close together when you put them on the boards, mountain. As you can see on the boards we got up on display here. And they come with short wires on there so you can take them and connect them really easy and for reuse as well. The other new one has been out for about a year now. It's out of stock currently, I see, because I was trying to purchase some ourselves for our team, is the Victor SPXs. Now this speed controller can be used in CAN bus or the PWM. So you got your choice there. And this also got some variations you can use with the control system for integrating sensors and coders and stuff like that as well on there. But these all have 4 wires on it, and then it's got the 2 sets of CAN wires on it. The CAN wires are always twisted with the green and yellow on it. So you have the green and white, which I'm not sure why they picked them 2 colors, but look at on these modules, and they'll have an M plus and a M minus. And that's what's going to be hooked up to your motor. Again, the black and the red will go back to your power distribution point that is fused on there for powering this module up. One of the modules you can put in here with these are all from CTRE, Across the Roads Electronics here, is the IMU stuff. This is one you can integrate right in with the Talons and the SPX Victors on here. There's a module for you can do your 3-axis stuff for doing your gyro driving autonomous on here. So this comes with a ribbon cable that you can snap right on that port of these Talons right here. There's 2 bolts that come off in there, and it's got a ribbon cable on there. So any encoders, gyros and all this stuff, when you're mounting this stuff, make sure that they're short. They don't recommend going a long ways with these encoders. I ran across the team at Worlds this past year that they were burning out Talons, and they had this long ribbon cable, and they went back and forth, tied it all together, and then went down to the frame. Well, what was happening is there was something that was shorted out in the ribbon cable, and it was blowing their Talons up. Remember, these Talons are $90 a piece. Don't make it seem like a lot, but it is when you start putting a budget together building these robots. So beware of how you're routing stuff, and we'll get into all that if you come to our electrical session next hour. Sparks, it's been a KOP the last couple of years. I don't know if they're going to do it in 2019 here, but this is a PWM controller. And these have a different type, where the other ones with the Victors and the Talons here have flying leads on it. That means the cable comes out of the body and it's just sitting there, right? These don't have that. They have screw terminals on there, different type of connection. This is where you'll have to strip the wire and put a connector on there and tighten it down on these terminals on here. This one can also integrate with these little pins on there. You'll see them in the upper right there, where you can put in a limit switch in there, right onto the controller itself. So again, these can pull a lot of power depending on which motor and what you're driving with them on these mechanisms. And this also has a brake and coast mode on there, just like the other 2 on there that I didn't mention. So you can see the difference. One's got the wires right there, pre-ready to go, terminal block, and bring it into your power and connect to your motors. And then this one's got the screw terminals on there. So all these go back to the power distribution, and what they recommend is that you keep them short. So you can see our boards up here, the Talons and all that, they go right to, they're right close here, so we can bring the wires right from the talons right into the power distribution. And if you can do that, it saves a lot of headache and wiring and trying to do your connections on there so you don't have loose connections on there. And then we use Anderson pole connectors so then we can reuse them in future robots. So,
But
yes.
if you have to add wires, it's better to add it from the power distribution to the controller or from the controller to the motor? Does it matter what side if you have to add?
Right, so good question. There's no real right answer on there. I like, as an electrical engineer in industry, I like to minimize my connections because connection points is a point of failure. And if you don't make these connections right, and these things pull a lot of juice on these drivetrains, I've seen the Anderson pole connectors melt. I mean, literally melt down, shorting out everything. So one connection point, and so what we've done on our team, we've always put the motor controllers close to the PDB and extend them out. So when we make our wires, we do the Anderson pole connector, and then that goes right down to the motor. And then usually we do a removable board, so we have a connector right there.
Well, that also reduces your can wiring, your distance of can wiring.
And your can wire is exactly like Travis just mentioned on there. So you got to think about total routing on here. You got cans or you got PWMs going all the way back, right? Pick your poison, what do you want to route back? And where are you going to put these things? So like the cans and stuff like that, again, you don't want them where they can be messed with or a chance that the wire's going to start breaking or fraying on that, because that's just going to cause nuisance issues. Your drive team's going to come back and say the robot's not responding. Well, there's multiple things that could be caused that. So then you start checking everything out. It could be a gearbox on there, which we just found at our last off-season event. The gearbox was, the motor was just flopping in the gearbox. But it could be the wiring. We had a wiring issue too where one of our connectors came loose. So wherever those, you want to make sure they're securely onto the frame somewhere and not able to short out. This is just a snapshot, a comparison of these. It doesn't have a lot of the new ones. There's an older slide. But the Jaguars, I don't think anyone should be using them. But they are still legal. A lot of people use them for their practice bots. And all Victors and SPXs right there at the end. But this gives you a quick snapshot of PWM versus CAN and the direction output with the voltages on there and how much amps, surge amps for 2 seconds it will draw on your batteries. So if you haven't seen it, the list is out there on the First Inspire's website for the current 2019 motor controller list, actuators and motors that are legal. I'm not going to go through them all. You can go look at it yourself on here, but if you got any doubts, they kind of announced that early and what's going to be legal for the new year. Spyke relays. Before the pneumatic control module came out, everyone used to use Spyke relays because these compressors will do a lot of current draw when they first kick on. Just think about a compressor at home or in your garage or something, right? It kicks on, what does the lights do if they're on the same circuit, right? You'll see the lights flicker. That's what these compressors are doing on there. So it's still legal to use them. A lot of people don't use them because that's what the control module will do for you on that. And then here's this more list of the actual motors and stuff, the new Redline motors that came out last year and that, and the other brushless motors are starting to make their way into FRC a little bit on a very limited manner right now. So this goes through the list right here. Again, I would encourage you to go to the website on that. So that's the first section of this. Are there any other questions about that?
Is there any motor controllers that, I guess out of all the controllers, is there any that are better for like heavy loads? You know, if you have like, you know, if you've got like a sim that you know you're really gonna be pouring the coals to, is there a controller that's better than the others, you know, be it Spark, Allen, SP?
Right, and that's where I would not use a Spark. I would use the robust ones. The Victor XBXs seem pretty solid, as well as the Talons are really solid in the design. The Sparks, the early reports were a lot of people were burning them out, and I don't know if it was connection issues or what on there. And I just don't like the screw terminal connections on them. It's a failure point. You got that plus your other connectors going back to the power distribution board. So it's something to consider. They say they can hold 60 amps, and if it's wired correctly with the right wire gauge, you should be fine with that. But it all depends on what the application, what you're really using that motor for. Not many people use it for their drivetrain. There is people that do it. You lose any other capabilities of running encoders and stuff into them. That's where their Victors, SPXs, and your Talons are really going to shine. If you're going to use it, but only spend the money if that's the direction you're going to go. So it doesn't pay to put a $90 controller on there if you're not going to use them features on there. You can buy the Victor SPXs, a really good controller, a lot of different capabilities as well on there, and they're $50 on there. So if cost is concerned, I would consider different things for what motors you're running. Sparks work good for intakes. I like them. The spin motors.
Can you recommend a connector to use on the Talon SRX?
Yeah, we use the Anderson pole connectors on them. That was the one Big Al was mentioning this morning. That was the other one. There was another one.
Yeah, we had a different connector.
Yeah, there was another one that I can't remember off the top of my head, but that's the most commonly one used is the Anderson pole, and that's because they connect. And with that, the Anderson pole connector has a way they snap in there, and sometimes when people run tape around it as well. But then if you have to replace them, say that motor burns out or the gearbox is shot or something's going on there, you can unsnap and have a pre-one ready to go set up, and you can just mount it mechanically, snap the wires together, and away you go. You don't have to think about trying to strip wires and find connectors and reconnect things on the fly.
So with the Anderson, you can screw those up pretty royally.
Yes.
When you're putting them on. We've had a Talon or two fail, but I suspect the connections.
Yep.
How do you test that? How do you test the connections after they're made?
Good question. We didn't really develop a test procedure at that, and we double check it. And I always do tug tests. And I do this at work on my panels. When the techs say, I'm done, ready for you to power up, first thing I do is I go in there and start pulling on the fuse blocks, circuit breakers, what have you, because there's been times where they don't get loose and they just come right falling out. I won't power it up. So in our electrical class, we'll go through that, and there's good online video that shows how to connect it, but as a testing procedure, I haven't really done it because usually it goes right into the motor windings when you come off of there, and you can test it back on there, but the key is to get it snapped right in there.
I would consider measuring the voltage across that connector.
You can do that as well.
Load with the motor, take your robot, put it up against the wall, and turn it on. And if you've got some bad connection there, you'll see a big voltage drop across just those two connector pins.
Sure. That's a good way of doing it. You can also look at it on the PDB or in the dashboard too. We can monitor the voltage draw on each of the slots on the power distribution board as well. But them are key because, like I seen it at the 10 key regional a couple years ago. They came out the field and they were melted. They were loose in the connection on there and sit there like arcing like this the whole match, and it melted them connectors. And so we cut them off and re-terminated everything before their next match. Good question. Here's another one that the FTAs love to call us on sometimes, is the robot signal light. If you miss that jumper, it's not going to do the little blinky thing. So here's just a reminder on there what to do with that. Here's how you do it. You can also just look on the module in there, but make sure that, and there's only one spot that hooks up to, and that goes all the way back to your Robo Reel. So on your robot design, again, make sure these two wires come back, and make sure the jumper's in there. Make sure everyone's happy when the robot's working for them, because it's a status light for everybody in the field. The wireless radio. This thing's been evolving for a while. At first was 5 volts, now it's 12 volts, and now you can run PoE on there. And we highly recommend it. And again, we're going to go in depth on this in our next session for electrical, is to make these connections right on here. Now the KOP one that came out last year, the year 4, was the orange one. Seemed like there were some failures with it, and we'll tell you exactly how we recommend doing it. But you can buy these PoEs off Amazon, 2 of them for the price of one at Handy Mark. And I have no stake in either company, but just a recommendation that these are, use the PoE. Some people like to run the barrel connection and with this, and that's perfectly legal on there. But again, if you make the good connections on there, you won't have any issues with it.
Kind of what Todd was just saying, running the barrel with that one, you basically, if you lose electricity via one, you have, it goes in the barrel and it backs up. So if there's anyone, doesn't quite get what that was, we did have where ours, we were having issues with electrical, and Todd said, well, run the barrel, so do them both. It doesn't hurt to have electricity going
Redundant.
different ways. You're always covered that way, and it did. We never had an issue after that. So
There's variations on the barrel connection. Andy Mark, I think a couple other ones sell it as well. The barrel connection goes in there and it has a screw terminal on there. You can take 2 wires and go back to your VRM on that. But you got to be careful on the barrel size because some of them don't make a good connection and the barrel is actually the wrong size to fit that connection on there. So be aware of that on there if you do that. Our recommendations as CSAs and stuff, we're going to force you to, or kind of recommend strongly that you use the PoE on them, on the connections. And again, we'll go through that because they'll power one way, and so you're not putting power to the Robo Reel as well. So as PoE injector, there's just a little bit about the radio on here. We'll get into the mounting and all that maybe in the next session, but be cautious when you're laying out your robot where you can put that radio. Because number one, when you get to the competition, the first thing you got to do is pull your radio to go get it reconfigured for the field. So place that's accessible and it can be easily removed. And number two, you want it out in a nice position so the field can see, hide it somewhere. And your critical pieces is your connections on there. Because if that radio goes down, you're going to be down for almost 60 seconds as that thing reboots and you're sitting there watching the rest of the match play. So these things all play a role in your little short 2.5 minute match. So here shows the PoE connected. It connects right to the radio, sends power from the VRM there, and you can see how it goes in the connector and that blue cable goes to the radio. That's sending the power. The other one's just slaving it off to the Robo Reel. On connection, you're done.
You do have to watch out your PoE injectors. If you buy ones like any mark ones are fine, but there's 2 different standards on the PoE injectors. There's ones that have power on only 1 wire versus 2 wires. So the 1 wire ones, I think, probably they have more chance of them dropping during matches if they can hit some things like that.
Mm-hmm. Absolutely. So this is the one off of Amazon that we had ran all year last year and this previous year. And you can see it's got barrel connection on there, and we just cut that off and then we strip the wires back, solder it, and shrink tube each end of it. So the Robo Reel here. The Robo Reel has a lot of features on this Robo Reel, and it's a big upgrade of what they used back in 2014. It's got 2 USB ports on there. It's got a USB A to B connection on it, which you'll use to do all your configuration to it for your imaging and firmware updates and all that on there. So if everyone doesn't have an A to B Ethernet cable or USB cable, I strongly recommend getting one. The CSAs all carry one, but it's nice to have that if you can't have your Ethernet connection working correctly. It's a good way to go into it. The other one is the power input right there. These can be a little tricky connections to use on there. There's 2 little bolts that go down in there in that black connector because it's almost impossible to wire it while it's on the Robo Reel. So I'll take that off and then do my connections to it, and that feeds the 12 volts to it right off the power distribution board again, fused on there, and then bolt it back down onto the board. Then you can see on the left there the CAN wires on there. It says right on the Robo Reel the yellow and the green wires, so please use that wiring scheme and keep them wires consistent throughout your system. Then it's got some other ports for communications for IMUs and stuff, for gyros and stuff like that. They got an SPI ports on here. They actually have the custom electronics port there, or the NavX boards and all them can go on there. You got all your digital I/O points on there. And then you can see the robot signal light down the corner. It's a 2-pin wire there. It's got the ground little symbol on it as well as the little plus sign there. And then match that up with your light that goes on your robot somewhere that's visible. You got relay controls, some analog inputs for sensor feedback. You can put in there. And it's got your standard reset user buttons there. And then there's your PWM ports there. 3-pin thing on there. Usually it's these cables right here that are all put together here with your white and your red and black on there. And then we'll just make sure you reference which way they go to match up with your device that you're plugging into it. And then it's got the LED status on there to tell you if it's powered, if it's in tele, you have all that stuff that comes on them lights as well. So the Robo Reel, it's a device that was created by National Instruments. It's a real-time Linux OS on there, which is most of the National Instruments have on there. They have 3 ways to mount it on there. There's you can just do zip ties, tie down, or run both into place. I wouldn't recommend zip ties, but you certainly can do that. You don't want that thing flopping around during a match. There's also, if you come up and look at our board afterwards, you'll see we have a little piece of polycarbonate underneath there that you can run 440 bolts into the bottom of the Robo Reel and then mount that plate onto your robot electrical board. This is just a quick overview of some of the features on there. Again, you can go back and look at the full manual if you want on here. It kind of explains the things I just went over on there. On your expansion ports and stuff like that, you can integrate onto it. This is the brains of the whole robot. Everything runs through the Robo Reel to talk to all your devices. Through the radio, through the fuel management system, and back to your driver station. Again, if you don't make a good connection with this thing will reboot a lot quicker than your radio. This is probably roughly 20 to 30 seconds reboot time. But if you don't get them wires in there correctly and have good solid connections on your Robo Reel, that will give you nuisance random issues on the field. Yes?
What do you think is a better way for strapping down each part of the robot? Bolting it or using a set of tape?
For which specifically?
Or like just in general, or just like depend on different parts of the robot?
Yeah, there's different parts have different bolts you can use to mount them on here. We've gone to the perforated board now style on here, but we've also done sub panels like this that you can mount things on there and make a good solid thing. 'Cause you don't want things moving around. Even though there's not a lot of pushing and bang, but you're going to get hit, you're going to bang. You might just drive the robot into the wall. Who knows? Your Thomas code might do that. You never know, right? So you want things secure on there. And we found one reason I was working at, every time they moved their manipulator, it was hindering their radio wire. So every time they move the arm up, radio would cut off. So there's other parts of the design you got to be aware of when you're designing. Yes?
So is there a standard board that you're using that will fit with a lot of the bolt holes on all those things?
No. I have a guy at work that designed a lot of them out that you can make pieces like that to mount the mounts on there. People are doing a lot more 3D printing now, mounting systems to put them all together. There's a lot of different variations on that. Even these 1/4-inch holes here, it doesn't match well sometimes on there. That's why we'll take another piece of polycarbonate on there, thin stuff, and then bolt everything to that and mount that to our actual electrical board. We've used wood. We've been primarily using the perforated boards now.
It's really good too to make sure that you keep that thing relatively serviceable. There's a lot of times, I'm telling you how many times at competitions where we've had robots not working because metal shavings got into the Robo Reel pins.
Yes.
And you take them apart and you'll find stuff at the bottom of them.
Right.
Happened in the off-season this year.
Correct. I mean, I fought one for like three different matches. We were pulling every PWM, see if it will, and we found little metal shavings, little tiny one, shorting out 2 pins that was sitting there wiggling enough for it to work a little bit and then stop working. Work a little bit, but it took forever to find it between matches.
Also, sometimes if you're trying to make a connection, your wire could be too big or too small to fit.
Yep, that's why you use
So I
the
think
rules.
just go, or and you're spending like half an hour trying to shove that sucker in.
Oh, you gotta use the right wire size. So a lot of people, there's there's models out there for doing 3D print stuff. Some people just put electrical tape over it. But as you can see in our design, we always use removable boards. So we do that for a couple reasons. You know, one, if we need to service that, we can just pull it out to get access to some mechanical pieces on there. But then two, we can build this, put it on the bench, and we can do programming testing without caring what the mechanical guys are doing on the robot. And do a lot of testing because we have breadboards of motors and stuff we can spend. Without getting into a lot of detail, this is your digital I/O register configuration. So, you know, I'm big on showing students, here's what is in the manual. Because in industry, if I don't understand how to wire up a device or design something, I have to go look it up in the specification and the documentation from the vendor. So the same thing here, it shows you, you can go in here and check out and make sure you wire it right for your analog inputs, outputs, and stuff like that. So full manual will be installed with your installer this year as well as previous years. Custom electronics, that's where you can get into your max port stuff here, your expansion ports for anything you want to do here, custom circuitry and stuff that you can do, follow the rules of the game manual every year. So here's a little more details on the CAN bus stuff, right? So around the Robo Reel, you can see it's got the L and the H for your green and yellow wires. This is the only way to wire it up to ensure it works properly. One thing you want to pay attention to, here's the big question we usually get. I'm not using any Talons or any other speed controllers that require CAN. I'm not using a pneumatic control module. Do I have to wire the CAN wire to the power distribution board? And the answer is yes. Everyone should have a minimum of 1 set of wires run from Robo Reel to the power distribution board. That gives you a lot of data on your driver station for your what's pulling current on there and your voltages on there if you have any issues on there. Plus it gives them, see what the firmware version is on there. There's a jumper on there that you need to pay attention to. It's right there in the corner where the CAN comes on the power distribution board. This CAN requires a 120 ohm resistor to loop it back. If you do not have that in there, you will not get any communications to any devices. So you can buy little CAN splitter modules that will have that in there, and that's perfectly fine, and whatever works for your design is what I recommend. But if you don't, a lot of people will just run it back and make sure the jumper's in there to get your loop back on your 120 ohm resistor there, okay? So again, if you don't have that, you can't see that when the programmers do that, make sure you look at that for your jumper on that location there. And again, these are all twisted pair. Batteries and circuit breaker connections. One of the top reasons robots fail on the field. Super, super critical. I can't tell you how many times I've walked up to a pit and you put your hand in here and just wiggle either the wire on the battery or off of the circuit breaker, and it's just free moving. Horrible thing to do. So again, we're not going to cover in there, but something to be aware of. Make sure your battery terminals and your circuit breaker is on there and wired correctly. Any questions on part of that?
I have a comment.
Yes.
On all those screw terminals, every time you run a robot, there's a voltage drop. However minimal, it's going to heat that terminal up. And as it goes hot, cold cycle, you're doing it, it's going to loosen those nuts. You got to check them.
Yep. It should be on your checklist. So everyone should have a PreMatch checklist. We've gotten stung by it before. Joystick's plugged in wrong, whatever. Someone didn't put a fresh battery in there. So great point. That's everything, not just electrical. Check your bolts and stuff on your gearboxes. If you do that regularly, you're going to prevent something that's going to break on the field. Yes?
Does low strength Loctite just a bad idea for these things?
I've used the Loctite on them things, absolutely. I wouldn't use the red or anything, but blue on there would be fine. You know, and just check them. You don't check them every match, but that's something, boy. You get in the morning matches, everything should be tightened and ready to go. Check it at your brakes on there. So that's basically the overview of that. There's 3 officially sanctioned support languages in FIRST, just to talk about the Java, C++, and LabVIEW. So if anyone's got any questions, let me know. Or else, have a great day. Thanks to everyone coming to the first session on the FRC control overview.